first lecture for the class 9 mathematics number system. The chapter name is number system. Before going to start this chapter, what is the number system? We have to this knowledge of some other number. So here our first topic will be basics of number. So here in your earlier classes you have studied that what is the natural number. The natural number started from 1 to infinite, that is all the counting number is your natural, and then when we include 0 on it, it become your whole number. This collection is known as your whole number, and whole number, that is 1 and all the positive number. When we add the negative number also in it, it become your integers. That means integer is collection of all these. Then integers and fraction makes your rational number, and the rational and irrational makes your real number, and this all collection is your number system. This is the basics for the number system. Let's take the definition of these number. So first is your natural number. Natural numbers are used for counting, that is 1, 2, 3, 4 are called natural number. The collection of natural number is denoted by n, capital N, and that is n equal to 1, 2, 3, 4 and goes on, so on. Then your second is your whole number. All natural number including 0. That means when we include 0 on it, it become your whole number. Then the next is your, and we will denote the collection of whole number with the help of capital W, and it is your 0, 1, 2, 3 and goes up to. Then your integers, that is what is the integer? The collection of all whole, positive and 0 and negative natural number are called integer. That means collection of integer is denoted by capital Z or I. We can denote it with the help of I also and Z. So Z equal to, this one is, we can write here all negative numbers. So we have, suppose here 4, minus 3, minus 2, minus 1 and 0, and it is now 1, 2, 3, 4. Then it is rational number. The number which can be expressed in the form of P upon Q, where P and Q are integers and Q does not equal to 0. That means here P and Q should be integers. It can be positive or negative. The collection of rational is denoted by capital Q. Then we can write it here as Q equal to P upon Q, and where P and Q are integers. One more condition is there, where P and Q numbers are co-prime. And then at last, what is the irrational number? That means those numbers which are not rational, that means which we can't express in the form of P upon Q, are known as irrational number. So here some example of irrational number are root 2, root 3, root 5 and any prime numbers root and pi. There are so many other examples. So these are your irrational number. Now today's our topic is representation of rational number on the number line. So here today's topic is representation of rational number on the number line. In earlier classes you know that how to represent the whole number, natural number, integers on any number on the number line. So here in this class the topic is representation of rational number. So here we have take a question. With the help of this question we will learn how to represent a rational number. So here the rational number is 1 upon 5. We have to represent this on the number line. This is your 1 upon 5. This is a rational number. We have to represent this on the number line. So we are doing this question within a step. This will make the question easy. So first step we have draw a number line. So we have draw a number line here and we have represent here as a 0 because it is 1 upon 5. It is a positive number, so we will represent it on the right hand side of the 0. So here now the second step is divide the number line into 5 equal parts. Why the 5 equal parts? Why we are not dividing it into 10, 8, any other numbers part? Because on the number line, on the rational number 1 upon 5, on the denominator is 5. On the denominator is 5. The denominator tells us that how many parts we have to make. Here we have to make how many parts? It is your 5. So we will make here 5 equal parts. So here it is 1, 2, 3, 4, 5. We have make here 5 equal parts. Now the third step will be name the first division as 1 upon 5. So here we will write here 1 upon 5. We will write here 1 upon 5. Here 2 upon 5. Here 3 upon 5. Here 4 upon 5. Then 5 upon 5 and 6 upon 5 and so on we can write here. Okay, so here 5 upon 5 means 5 upon 5 become 1. That means it comes between 0 and 1. So between 0 and 1, how many parts we have make? 5 parts. 1, 2, 3, 4, 5. So on the denominator, each and every rational number we will put 5 because on the main rational number on the denominator it is 5 and we are dividing here into 5 equal parts. We have make here 5 parts just like 1, 2, 3, 4, 5. That's why we are on the denominator we are writing here 5. So that means it is 1 upon 5. The question was we have to represent 1 upon 5. So it will be represent where? So this is your representation of the 1 upon 5. So here we have take one more number just like 7 upon 9. Here we have changed the number examples 7 upon 9. On the denominator it is 9. So how many parts we will make? 9 equal parts. So we have drawn a number line. We have divided into 9 parts just like 1, 2, 3, 4, 5, 6, 7, 8 and 9. We have drawn it so on, but we need only this one. That's why we are using this number. So on the first one it is 0 upon, you can also write here 0 upon 9. Okay, you can also write here 0 upon 9. So first division is 0 upon 9. Then here we will represent 1 upon 9, 2 upon 3 upon 9, 4 upon 9. This is 5 upon 9, 6 upon 9, 7 upon 9, 8 upon 9 and 9 upon 9 will make 1. Okay, so 7 upon 9 will represent where? 7 upon 9 is this one. If we will write here 10 upon 9, 11 upon 9, 12 upon 9, 13 upon 9, 14 upon 9. If any other number, just like you have to tell that where is 9, 11 upon 9 represented. Similarly, we will do this one and the answer will be here. Okay, so this is your representation of rational number. Our next topic is rational number between two rational number. This is our new topic. So here, before going to how many rational number between any two rational number, you have to tell me that how many natural number are between 5 and 11. How many natural number? How many natural numbers are between 5 and 11? You can easily tell that it is 6, 7, 8, 9 and 10. These are 1, 2, 3, 4, 5. These are 5 natural numbers between 5 and 11. Same as if you will ask to you that how many integers are between -5 and 2. Okay, how many integers are between, now you have to tell how many integers are between -5 and 2. These are -4, -3, -2, -1, 0 and then 1. You can easily count again. These are 1, 2, 3, 4, 5, 6. Okay. These are the simples for the natural number, whole number also you can take, and integers. Now here we will learn that how many rational number are between any two rational numbers. Suppose I have asked you that how many rational number are between 5 upon 10 and it is 7 upon 10. How many rational number you have to tell now. How many rational number? Okay. So here it is, first one is 5 upon 10 and this is your 7 upon 10. So you will see that 6 upon 10. Okay. You can see that it is 6 upon 10. But what about if I will write that this one 5 upon 10 is as 50 upon 100 and it is 70 upon 100. Now you will see that you can say 51, 52 upon 100, 53 upon 100, 55 upon 56 upon 100 and goes on up to 70. Okay, you can say that you will say that it is 51 upon 100, 52 upon 100 and goes on up to 69 upon 100. Okay, now you will count it again, and if we will I say that to you that what will be if there will be, now there is, I have written these. Now can you tell me that how many? Again you will see that you will say that these are your 5001 upon your 10,000 and 5002 upon your 10,000 and goes on up to here. Okay, so again you can count. So if we will take like this, can you tell me that how many rational numbers are between any two rational number? These are your not definite. Okay, these are your not definite. That means these are countless numbers between any two rational number. There are countless rational number between any two rational number. You know that there is a countless rational number between any two given number. Okay, earlier we have studied that there is countless rational number between any two given rational number. So we have take here one question, that is your find the 10 rational number between minus 2 upon 5 and 1 upon 2. We have to find 10 rational number between 2 upon 5 and 1 upon 2. So our solution part is, here the first rational is 2 upon 5 and the second rational is 1 upon 2. The first thing we have to make their denominator same. Here the first rational number, in the first rational number there is denominator is 5 and the second one it is 2. So firstly we have to make the denominator as same. So we will take the LCM of 5 and 2, it will be your 10. So making it as 5, 10, we will multiply 2, and here making as 2, it's multiply by 5. So it become your minus 4 upon 10 and here it is 5 upon 10. Okay, so now it is minus 4 upon 10 and it is 5 upon 10. Now you will tell that between minus 4 upon 10 and 5 upon 10, how many rational number? You will say minus 3, minus 2, minus 1, 0, 1, 2, 3, 4. Okay, and then comes 5. So it will be on the denominator, what we will write, it is 10 and it will be your these rational number. There it is 1, 2, 3, 4, 5, 6, 7, 8, only 8, but you have to find 10 rational number. So now our next step will be, if you have to find any 5 number, the question was find any 5 rational number between minus 4 upon 10 and 5 upon 10, you can easily choose any 5, but here the question is you have to find 10 rational number. So now you will do 4 upon 10 and here it is 5 upon 10. You will multiply these two number, on the numerator also 10 and on the denominator also 10. Same as here, on the numerator with the help of 10 and on the denominator is also with the help of 10. So it's become now minus 40 upon 100 and here 50 upon 100. Okay, so now between minus 40 upon 100 and 50 upon 100 there is so many number, that is your minus 39 upon 100, minus 38 upon 100, minus 37 upon 100, and it goes on up to 49 upon 100. So here there is so many rational number between minus 40 upon 100 and 50 upon 100. So you can choose any of 10 from these here. So your answer can be vary from your friend answer, because there is the main thing is countless rational number between any two rational number. So here now you can choose any 10 number between these, so that will be your final answer. The real number is consists from rational numbers and the irrational number. And the rational number, you know that in the form of P upon Q, these called your rational number, where P and Q are your integers. So here we have take some two example here, that is first one is your 1 by 4 and second one is your 2 upon 3. When we will divide the 1 with the help of 4, okay, we have to convert it into decimal form. So we will divide the 1, that means numerator, on with the help of their denominator. So in this case we get here the remainder is 0 and the quotient is your 0.25. That means remainder is 0. That means it is completely divisible. So we can say that this is your terminating form. When the remainder is 0, that means when the remainder is 0, it is your terminating term. Now the second one is your 2 upon 3. Second rational number is 2 upon 3. That means on the denominator it is 3 and the numerator is 2. So we will divide 2 with the help of 3. So here this one is when we have divided 2 with the help of 3. In this case we get the remainder as 2. Okay, and every time when we divide it, that means in the first step 3 6 are 18 and again remainder is 2. When again we have increased the 0 and it is 3 6 are 18 and again 2, and this process is goes on. Okay, so that means in this case remainder is not 0. Remainder never become 0. So this type of term is your non-terminating term. But in this case there is one thing you are saying, that the number is here in the quotient, it is repeating, that is every time when we divide it, it goes on 6 times. That means we can write it 2 upon 3 and it is 0.6, and on the 6 we have put the bar. The bar is representing that the number is goes on, it is not ending. In the non-terminating term, there is two case arises. The first one is when the term is repeating and recurring. Repeating and recurring both are same. That means in this case, when we divide, every time we get 0.666 and it goes on up to. That means here the digit is 6 is repeating. So we will call it non-terminating and repeating terms. Now so in the rational number we conclude that in the rational number the decimal expansion is terminating or non-terminating repeating. Okay, in the rational number the decimal expansion can be terminating or non-terminating repeating. For the irrational number, we have taken, so first is your non-terminating. For the non-terminating term, when there is we have choose one number, that is your pi. Okay, so we have taken the value of pi is 22 by 7. It is not the fixed value, we have taken it as approx value. When we divide 22 with the help of 7, we get the number as 3.14159.265 and other number also. So it is not also ended here. So here no one digit is repeating. That means this term is known as non-terminating because the remainder is not 0 and there is not any term is repeating, that means non-repeating term. So this is your irrational numbers expansion. That means at the last we can say that in the rational number the decimal expansion is terminating or non-terminating repeating. But for the irrational number the decimal expansion is is our new topic, how to represent the irrational number on the number line. In earlier we know that how to represent the irrational number on the number line. So now we have to represent also the irrational number on the number line. Here we are solving this with the help of taking one question here. The question is locate root 5 on the number line. Here root 5 is an irrational number. We are doing this question within a step. This will make our question easy. So the first step is here. The number whatever you have given, that means the irrational number, is here it is your root 5. The first step is you have to write the irrational number as the sum of the square of two natural number. Sum of square of two natural number. So here it is 5, irrational number root 5. So we have taken the 5 as number. We have break 5 as the square of two numbers, so it become 5 equal to 4 plus 1. 4 is the square of 2 and 1 is the square of 1. So it is now 2 square plus 1 square equal to 5, because 2 square 4 plus 1 is 5. So here the greater number we will choose as 1 and the smaller number we will choose as B. Now the second step will be the second step will be, we will draw a line, that means that will be your number line on the horizontal line, that means number line represent A and the vertical is your B. That means A is how much length? 2 centimeter. So with the help of the ruler, you will take it and mark in here 0, mark it here and 0 and put it on it, and this is your 0 to 2, because A is your 2 centimeter. We have taken here A is 2, so there will be 0 to 2 is your A, and from 2 you will do a perpendicular line of the which length? 1 centimeter, because B is your 1 centimeter. So this length is your 2 centimeter and perpendicular is your 1 centimeter. So that means we have put the name here, it is your O and the perpendicular is your A and this is your B. That means AB is perpendicular on OA. This length is your 2 centimeter, this is your 1, this is your A, this is your B. Then join O to B. This is your in the second step. Now in the third step, this is your a triangle. This is your triangle OAB, a right triangle. So it is a right triangle. This is your 2 and 1. So we will use the Pythagoras theorem. In the Pythagoras theorem, this is your hypotenuse OB. So OB will be under root OA square plus AB square. That means 2 square plus 1 square is equal to root 5. That means OB is the length of root 5. Now at the last step, in the fourth step, you will take a compass and put the pin of the compass on point O and the second pencil snap on the point B. Okay, on the point B. Without disturbing this, take it as this and mark on a number line. The mark goes on this point and we have named as C. So this become the distance O to C represent your root 5. That means root 5 is irrational. Now it represent on the number line. It is this OC is equal to root 5. Same as with the help of these, you will do root 13 and root 3. Root 13 is the sum of how much? That is your 9 plus 4. 9 is the square of 3 and 4 is the square of 2. And same as